Hi, this is Henk Akkermans, and this is Smart Asset Management Lecture 9, Integrating Asset Management IT Systems. IT systems for asset management are, you could say, a special case of all the IT systems that are used in production firms, in technical firms. And personally, I have a long history in those, up to some 20 years ago. I work, for instance, in ERP project management, and I thought I'd left all that behind me, but apparently not. But let's take a quick recap of history. So going back to the EOQ formula of in the early 20th century, production was not the area in which there was a lot of IT being used. Actually, around the start of my own career, 1970s, 1980s, there were mainframes in firms. There were IT-enabled solutions for information systems. Usually, all the accounting, the bookkeeping was done on IBMs, and in the factories you had fax computers. But basically, those two functions then, accounting and productions, those were the functions that were IT supported. Later on, or later at around the same time, you got MRP, and MRP has this great concept of translating sales orders into production orders and even time-based into purchasing orders. So that was a significant improvement there, because that meant there was one system to really coordinate the entire flow of goods through the production organization. Later on, with MRP2, companies realized, and consultants and IT vendors, etc., that to do so without taking into account the limitations in capacity was risky. And so the main sources of capacity, usually people and machines, had to be incorporated as well. So that meant there was some not material requirements planning, as MRP was then used, but manufacturing resource planning. And as a result of that, gradually you could track more of personnel, and so you could also do some payrolling, and you could also start to track more of the assets, which is then the nucleus, you could say, of our asset information systems. As MRP2 grew into ERP, other functions were integrated around the late 1990s, just before the millennium bug would or would not hit companies. There was this ERP crusade, you could always almost say, where many of the patchwork of individual IT systems, legacy systems of firms, were integrated into these big software packages of SAP, BAN at that time, Oracle, and what have you. So those also integrated services and field fleet management, MIS functions, and engineering, yes, although not so much so, because those used to be standalone systems working on workstations with high specific hardware requirements, and still pretty much a black art, you could say. So if we talk about enterprise asset management today, it has to do with some of these functions. Yes, engineering is a bit in there, maintenance is now a new function, the assets are in there, and service on the assets, especially if you're a manufacturer of equipment. The MRP2 systems had that, well, they had some, I could even say beauty. This is a slide from, a picture from a book from 1919 from Wil Bertrand, Hans Wachman, and Jacob Wijngaard. Three of the great minds of those 1990s and beyond, on thinking how to use IT IT and for production control for manufacturing. So this is the standard MRP logic where you say I have a plan to make something that creates an MRP, an MPS, a master production schedule that translates into material requirements. Those material requirements are translated time-based into requirement records. That means that you have to source and get capacity plans, and then you get order release up here. And parallel to this, you have the capacity planning. So that's a very coherent, structurally tight framework, you could say. And that was great in the 1990s. So it may be with some frustration that somebody like Hans Wachtman, one of the authors of that early work, now in the 30 years later, basically, is still working on making this conceptual clarity also set out in practice. And Hans did wonderful things both in theory and in practice. There it was set even for a while on the board of Baan, which is one of the early successful ERP vendors. But still, this is what Hans Wachtman presented at the World Class Maintenance Summer School some 2 years ago. Said, yeah, basically we have some engineering tools, computer-aided designs, plant analysis, and we have some document systems where we have configuration management of what is in the plant, some product data management, and we have what's then most the ERP side of it, asset maintenance management like Maximo or SAP, where there is an asset master file including the equipment breakdown structure, some spare parts, some finance. So those are the transactional systems. But still, it's a patchwork, you could say. There is no strong link integration between all of those, which is which was the logic that we need. Because indeed how to integrate and standardize asset information, that's what we need, because we have the asset information is needed across different functions and between different firms and across the entire life cycle. And that's then a big challenge. You don't have to standardize everything, even that also some almost 40 years ago, Mintzberg described some different kinds of flows where really ad hoc processes there's much less need to standardize those than say, the accounting, the annual accounts, or much of the regulated activities. And over time, more and more of this less structured data we are capable to capture in our big data analyses, as we'll see later on. But you really want to be around here, very much standardized, but that's not so easy. If you again look at the literature from that period of the ERP integration, then you see that there is the shared IT applications are separated from the local application, but much of the asset management IT system then is still that local application. It's not seen as part of the IT infrastructure, and that means again that it's perhaps not so needed to standardize this, and yet today we need it if we want to have all this smart asset management going. Another point that Hans Wachtman makes is that across the life cycle of the product, there is limited integration. There are separate people and functions doing the design and engineering of the assets. Then quite often building and constructing it is again a separate group of people, and there is some handover up here, but not fully, which you will see clearly if you talk about digital twins, for instance. Then these people in design engineering have a digital twin, but it's not automatically used here, and certainly not here. And then, of course, during the operation and maintain of the asset, again a handover to the next party, and that handover is broken in many cases. And it is, of course, difficult because inherently all of our asset management, smart asset management, moves across organizations. We've seen this picture several times. And that means that all of them have bits and pieces. The asset owner has much information about the equipment that they have, but the manufacturer has separate information, more detailed about how it can work. The service provider knows the information regarding the actual maintenance. Some supplier has some key data. So you need to share all this data across the service triad, and that's problematic. In fact, you can get some level of standardization there, but it doesn't happen automatically. In another article with Hans van der Horst, a former CIO of Philips, from again some 20 years ago, we looked at different kinds of standardization in general in IT. And you've got coercive standardization, where somebody says this is how you should do it. A classical example by the time was a conversion in the European community towards the euro. But nowadays it's more often collaborative standardization, which then still has different varieties. There are still some hierarchical order collaboration, like the GSM standard in telephony. But there are also voluntary collaborative standardization. The whole move into HTML, HTTP from internet was really a group of people agreeing on this is how we should do it. There can also be different consortia. Take the Unix consortia, of which you often end up with two standards. And there can be real competitive standardization. May the best one win, like take Windows versus Mac. Again, in this period of some 20 years ago, and ERP implementation was all over the place, some of my INSEAD colleagues and myself, and for Yuka-san and Luc Walsenhoven to be precise, and my former colleague then Paul Bogert, we did a Delphi study with some 23 supply chain management managers on if this ERP is coming for you, not in the asset management, but in the supply chain area, so the goods flow, will that actually be helping you? Well, most of them saw issues. They saw issues with the integration across the supply chain, with the flexibility needed to adopt to changing in the business practices, as these ERP systems were huge and not really flexible. Mass customization, who will be in the driver's seat? Many of these issues, and actually our experts mapped then on a 2x2 scale, on two scales, how much ERP would contribute to supply chain management and what would be the impact. And what you then see is that there will be some impact. There will be, of course, contributions to standardization, transparency, and global IT, but actually flexible requirements, extended enterprises, integration through IT systems, and certainly outsourcing and who's in the driver's seat. All those were seen as, well, a significant business impact, but actually a negative contribution on ERP. ERP, because it's by definition an integrated, nice, as we saw earlier on from the RMP figure, it's very nicely, coherently structured around what happens within a firm. That makes it more difficult to translate it into a world where there's a network. Those same mainframes that work so very nicely, the IBMs in accounting and the Faxes in the factories from the 1980s, still have some linger on in the architecture of ERPs. Although you have client server, although there are cloud-based solutions, and that is changing, but still is this the history where they're moving from. So 2 decades ago, the main complaint was that the extended enterprise functionality was lacking, the ability to support operations across multiple organizations. And I'm wondering 20 years ago what not vendors, but customers of ERP systems will say, well, no, that has completely changed. The flexibility, more management information system beyond the transactions, and the open modular system architectures. All those were seen as shortcomings of ERP systems back then. Now, what we've seen in ERP systems is that much of this has happened since then. But that's also because if you look at what's still called the Nolan Curve, going back to an article from 1974, when IT was still called EDP, electronic data processing, then ERP has moved from this initiation and configuration phase into much more control and integration. For asset management IT, that's not yet the case. If you take this is a laundry list of issues as known in the literature, as noted down by Jan Braaksma in about a decade ago, I suppose, in his PhD thesis back then on asset information for FMEA-based maintenance. And here you see there it's uncertain whether information in the future will be needed. The maintenance knowledge isn't sufficiently accessible. It cannot be used without additional knowledge. Maintaining the quality of the data is complex. There is a heterogeneity of storage applications, so really the patchwork, the island automations, all these data are stored in non-integrated systems. There are many handover problems, the classical problem of asset data between maintenance and engineering, for instance, one, and there's a lack of information standards. And this was then true in the process industries a decade ago. And although things have improved, all these problems are not solved yet. So there's work to be done.